Section 1.4. This is the last section in this chapter, which has been review from last year. And this new section is on rewriting equations. After we're done with this section, we'll be ready for a chapter test. So, do you remember solving for y? Taking equations, solving them for y? We use this a lot when we're graphing, especially linear equations. We also use this for our substitution method of solving systems of equations, and hopefully it's not too big of a stretch for you to remember this. The big idea here is that we are reversing the order of operations. So we have our order of operations, grouping symbols, exponents, multiplication and division, addition and subtraction. So when we're solving for a certain variable, we're solving for y. It basically means we're trying to get y by itself by going backwards in the order of operations to try to peel off the layers, get everything away from y. So we're going to look at first, again, moving backwards, addition and subtraction. So we're looking at this term as a whole and saying, how can I move all the other things on this side, in this case using addition and subtraction. So the other thing that's with this negative 2y or minus 2y term on the left-hand side is the 8x. So, thinking addition and subtraction, we want to reverse or undo what's already being done. And even though the 2y is being subtracted, because the 8x is positive, we are going to think of it as, okay, this is like a plus 8x. So to move it to the other side, it becomes a minus 8x. So minus 8x to both sides. Minus 8x to both sides. So plus 8x minus 8x, they conveniently cancel out, which was our whole goal. And on this side, we still have the minus with the 2y, so we have minus 2y. And on the right-hand side, these are not like terms, so we can't combine them. So we're just going to write them over again. You could write 18 minus 8x. We just tend to usually write the 8x or the x term first, so I'm going to write this as minus 8x plus 18, so this is going to look more like slope-intercept form. And then, again, we're still aiming to get our y by itself. So we've taken care of addition and subtraction. Now we'll look at multiplication and division. The negative 2 is being multiplied by the y. So to undo that, we're going to divide both sides by negative 2. And I can either write a big division sign under the whole side, divide by negative 2. Or what's going to be more useful for simplifying purposes in this case is divide by negative 2 to each term on both sides. So it's essentially distributing the division. Usually when we have parentheses, we distribute a multiplication, but we can also distribute a division, no problem. On the left-hand side, the minus 2 cancel, or the negative 2's, we leave with y. And on the right-hand side, negative 8 divided by negative 2 is positive 4x. 18 divided by negative 2 is negative 9, and that would be my final answer. Y is by itself. I got a y equals solve for y. So again, solve for y means we want it to end with y equals something. Let's take a look at the next example, number 2. I have 3x minus 5y plus 11. And in this case, I could subtract the 3x and the 11 both to the other side and then divide by negative 5y. But it will actually be quicker to get y by itself if I move this negative 5y term and just move that one term instead of moving the other two. So it's a minus 5y. I can move it to this side because right now there's just a 0 there. There's nothing there, and it will already be by itself. So if I go plus 5y to both sides, then the minus 5y and the plus 5y, they will cancel out on the left-hand side, leaving me with 3x plus 11 equals 5y. Get the y by itself. 5 times y, the opposite of that is dividing the y. Oh, sorry, dividing the 5. So divide out the 5, divide out the 5, divide out the 5, and what I've got is 3/5 x plus 11/5 equals y. Now if you wanted to, you could turn those into decimal numbers if that helps you, makes you feel better. You could also rewrite this as y equals and just swap the sides. We can do that without changing anything when there's an equal sign in the middle. No problem. Alright, so I like fractions. I'm okay with fractions, and the fractions, especially with the slope when I'm graphing a line, is going to be helpful for thinking rise over run. Just kind of a preview of what's to come. Alright, pause your video here. Try numbers 3 and 4, then come back and we will work through the solution. All right, here we go. So in number 3, we've got this x all by itself with a 3y term, I'm going to remember that an x by itself is actually like a 1 or a plus 1x. So to move it to the other side, I'm going to subtract 1x, minus 1x, minus 1x. And you don't have to write the 1 here if you don't want to. It just kind of makes life a little easier when we divide out this negative 3 to make it obvious that this is going to be a 1/3 if you're thinking slope, and 14 over 3, negative 14 over 3. So there's the first one. And number 4, we're going to subtract the 7 to the other side, x minus 7, divide the negative 2, distribute that, and that would give us our final answer for number 4. All right, now we're going to take a look at some formulas that don't use x's and y's. Here we have some common area equations that you should be familiar with. The first one, a equals 1/2 base times height. Think about that one. Recognize it? That one is a triangle. Number 6, area equals pi r squared. You know that one? That one's a circle. And the last one, area equals 1/2 base 1 plus base 2 times height. That one might be less familiar to you. That one is a trapezoid. Trapezoid is your figure that looks kind of like this. The top side is your B1, the bottom side is your B2, and your height is from between those two. So, when you're given these kind of area formulas or different formulas in geometry or in physics, a lot of the time we're given repetitive questions over and over again where they give you a whole bunch of areas and a whole bunch of heights and they want you to find the base for each one. So say the first one, you're given an area of 5 and a height of 2.5, so you plug in the numbers, solve for b. Then you're given a height of 52 and an area of 100, you plug the numbers in, and then you rearrange to get b by itself again. When you're given a whole bunch of repetitive stuff like that, or when you need to substitute in to another formula for b, that's when it's especially useful to be able to solve an equation for b, or another variable. So let's see how this works. For number 5, we have a equals 1/2 base times height, and they're telling us we want to solve for the base. So again, I'm thinking reverse order operations. There's no addition and subtraction, so now I'm looking at 2 multiplications. I have 1/2 times b and h times b, and I want to move them both to the other side to get b by itself. So I could, if I wanted to, divide by 1/2. But when you have fraction multiplication, actually, the best way to move it to the other side is to multiply both sides by the reciprocal. Because if I have something like 1/2, and I multiply it by its reciprocal, 2 over 1, so reciprocal means flip the fraction over, I have 2 times 1 is 2, 2 times 1 is 2, 2 over 2 is just 1, and it effectively makes the fraction disappear. So if I use that trick here, I'm going to multiply both sides by 2 over 1, which is actually just the same as multiplying by 2, and that cancels the 1/2 and the 2 over 1 because they just equal 1 on that side. And on the left-hand side, I'm left with 2a. I'm not going to bother to write it as 2 over 1 because just nicer, 2a. And on the right-hand side, I've got my b and my h. Now to get b by itself, I want to divide out the h to the other side. Divide by h, and I'm left with 2a over h equals b. Or you could change those sides and make it b equals 2a over h. Either way is fine. So that's one trick. If you have a fraction that's being multiplied and you want to move it to the other side, multiply both sides by the reciprocal and it will cancel. Saves you a bit of division. Number 6, circle. A equals pi r squared. I want to get the r by itself. So thinking reverse order operations, there's no addition and subtraction. There is a multiplication, the pi times the r squared, so I'm going to divide that over to the other side. Divide that over to the other side, which cancels the pi's on the right-hand side. So I've got a over pi equals r squared. Okay, after a multiplication and division comes my exponent. So I've got to get rid of this squared exponent. So the inverse operation for a squared is your square root. So I'm going to take the square root of both sides. And I always tell my students, whenever you take the square root, it always comes with a plus and a minus. And the reason for that is because when something's squared, say -2, -2 squared equals 4. But 2 squared is also equal to 4. So if I take the square root, I could be dealing with either of these inside, and I don't actually know which it is. Sometimes the real life situation will determine whether you use the plus or the minus, and sometimes either one is actually a valid solution. So in this case, square root cancels the squared, and I'm left with plus or minus square root of a over pi equals r. Now in this case, because r is the radius of my circle and I'm never going to have a negative radius of my circle, I'm actually going to eliminate the negative option. I really only care about the positive option because my radius is going to be positive. But it's just a good rule of thumb to remember that whenever you take a square root, you always get a plus or a minus out of it, because a minus squared is going to give you a positive number. And so you have two options when you take a square root. It could be plus or minus 2. We don't know which one it is. All right, taking a look at number 7. Area equals 1/2 base 1 plus base 2 times height. And we want to solve for base 1. So you have actually a couple options of how to do it. If you wanted to get rid of your grouping symbols by distributing the 1/2 and distributing the h to both b1 and b2, so it would be like 1/2 times b1, 1/2 times b2, h times b1, h times b2. You could do it that way. But I'm actually going to take the, whoops, sorry, jumped back. Don't know why I did that. Wrong button. There we are. I'm going to actually take the other option of multiplying by the reciprocal and moving the things that are outside my grouping symbols. So the grouping symbols just kind of disappear on their own. So if I multiply by the reciprocal, multiply both sides by 1/2 flipped. So multiply both sides by 2 over 1. Just like we did in option number 5, 2 over 1. I've got 2a on the left-hand side. The 1/2 and the 2 over 1 cancel on the right-hand side. And I've got b1 plus b2 times h. Doesn't matter that this h comes afterwards. I can still move it to the other side by division. So times h means I'm going to divide out h. Divide out h, so I've got 2a over h equals b1 plus b2. And my grouping symbols just kind of disappear because they're no longer useful to me. There's nothing outside them anymore. So I could have the parentheses still there, but they're not needed anymore. Now to get b1 by itself, the only thing left over here is b2, so I'm going to subtract it to the other side. Whoops. And I can't actually combine 2a over h and b2. They're not like terms. So I'm going to be left with, I'm going to have to write my answer over here, run out of space, 2a over h minus b2 equals b1. And that would be my final answer. If you chose to go the route of distribution, your answer might look a little different at the end, but it's essentially going to be the same thing. All right, couple more. Why don't you give, these are some other common formulas. We got the simple interest formula, we got the slope intercept form, we got temperature formula. Why don't you go ahead and try numbers 8 and 9 on your own, and then come back and watch the solution. All right, these ones are pretty straightforward. For number 8, the r is being multiplied by the p and the t, so I can actually divide them out at the same time. And I get I over pt. That's it, that's my total answer. For number 9, the b is being accompanied by this mx term, and it's a positive mx, so I'm going to move it to the other side by subtraction. So y minus mx equals b, and that's it. All right, number 10, we want to solve for c. So to get c by itself, again, reverse order of operations, I'm going to take care of this thing that's being added first. So subtract the 32 from both sides. So I've got f minus 32 equals 9/5 c. And again, I could divide this 9/5 to the other side, but I'm going to choose the route of multiplying by the reciprocal. So I'm going to multiply both sides by, flip it over, 5 over 9. And when I do that to the left-hand side, sorry, I'm going to add in parentheses. I'm going to make this 9/5. And on the right-hand side, the 9 and the 9 cancel, the 5 and the 5 cancel, leaving me with just my c. I could distribute this 9/5 to the x, the 9/5 to the 32, but it doesn't really gain me anything, so I'm just going to actually leave it like that. 9/5 times f minus 32, and call that a day. Number 11, we want to solve for z, which is in the top of my fraction. And the first thing that I'm going to want to do to get rid of, basically to get rid of the fraction, if I'm thinking reverse order of operations, it might be tempting to go for addition and subtraction first. The problem is, remember that there's actually invisible parentheses around the top of a fraction, which puts me at the other end of my order of operations with my grouping symbol. So I want to deal with this division first before I deal with this grouping symbol, which is the addition and subtraction on the top. So I'm going to erase those invisible parentheses, but remember that they're there, which is why I don't deal with the plus x and the minus w first. I'm going to deal with the r first. So to get the z by itself, r is being divided, so I'm going to multiply it up to both sides. Multiply it to both sides, and when I do that, on the left-hand side, my r that I'm multiplying and my r that I'm dividing, they cancel out nicely, and I'm left with x plus z minus w, and a 1 times r on the right-hand side is just an r. Now to get z by itself, I'm going to deal with the additions and subtractions of the x, so I'm going to subtract off the x, add on the w to both sides, subtract x, add w, and what I'm left with is z equals r minus x plus w. Not too tricky? If you think you're getting this, pause your video, try number 12, then come back and we'll talk through the solution. Alright, so same as we did with number 11, we're going to multiply up the denominator to the other side. Doesn't matter if it's a number or a variable. We can multiply both sides by 2. Then we subtract the x to get the y by itself, and we're left with y equals 2a minus x. Alright, not too tricky so far. Let's keep going. We're going to skip number 13. We don't need to worry about number 13. It's kind of just a funny, it's supposed to be a joke, but it's not relevant to our school. Number 14 says, the Pythagorean theorem of baseball is used to predict the number of wins a team will have. And we're calling wins W, so there's one of our variables. When given the total number of runs scored, R for runs, the number of runs the opponent scored, A for opponent, I don't know, why A, and the total number of games played, T total. So we're trying to figure out how many wins a team will have if we know how many runs they scored, how many runs their opponents scored, and how many games that they played. We can figure out approximately how many games they won total. So we're going to solve the formula for W. We got W over T is approximately equal to R squared over R squared plus A squared, and we want to solve it for W. Not too tricky, because the only thing on the same side with the W is the T, so we're going to multiply both sides by T. And that means the t's on the left side cancel out. On the right side, you can think of this as a t over 1 to be able to multiply it as a fraction multiplication, which essentially means t and r squared end up on the top, and the 1 will multiply to the bottom, which doesn't change the bottom at all. So then w is approximately equal to r squared times t, or you can write it as t r squared, doesn't really matter which way, and on the bottom r squared plus a squared. That's it for part A. Part B, in 2012, the Yankees scored 804 runs, while their opponents scored 668 runs throughout the 162 games. So they played a total of 162 games. Estimate the number of wins the Yankees had. So in other words, we're going to use these numbers, we're going to figure out where to plug them in on the right side of our equation to figure out how many wins, how many W's they had. So the Yankees scored 804 runs, so there's an important piece of information, and we look back at our original runs scored was R. So we're going to put this 804 in where we have R's in our equation. Their opponents scored 668 runs, so their opponents, that was our A. So this is 668 is our A. Don't know why A, that's kind of strange. throughout the 162 games. That's my total games, that's my t. So I'm going to plug each of these numbers into my formula. So w is approximately equal to r squared, r is 804, times t, 162, divided by another r squared, 804 squared, plus a squared, 668 squared. I don't have a calculator that I can easily pull up onto the computer at the moment, but you each have your calculator. I'm going to plug it into the one that's sitting right in front of me. So 804 squared times 162 divided by, when I put this division into my calculator, if you don't have a fraction bar, you will need parentheses on around this. Otherwise, it's only going to divide by the 804 squared and think you're just adding this to the whole thing. So parentheses, 804 squared plus 668 squared. Close parentheses. I'm going to put parentheses here because remember that my fraction bar is like an understood grouping symbol. Hit enter, and that tells me the Yankees won approximately 841 games, which would round to 96 games. And in parentheses, they tell us the actual number of wins for the New York Yankees in 2012 was 95. So the formula gave us a pretty good estimate. All right, let's take a look at number 15. This is our last one. The total number of miles a honeybee can fly in its lifetime is modeled by the equation T equals m times d minus 21, where T is the total number of miles flown, so if you know how many miles they fly, m is miles flown each day, so total must be in their full life, m is each day of their life, and d is the number of days that they live, lifetime in days, minus 21. Some bees fly up to 55 miles per day, and their muscles can fly a total of 500 miles before giving out, and the bees die. So this is in their lifetime. This is per day, this is in their lifetime. Solve the equation for D, and find the total number of days the bees live. So I'm going to take this equation, I need to solve it for D. So to get D by itself, I could distribute the m, but I think I'm going to actually divide it to the other side. That just seems nicer. So divide by m, so I've got T over m equals D minus 21, and my parentheses just going to disappear. And then add the 21 to both sides to move it to the other side. Can't collect any like terms, so I'm going to end up with T over m plus 21 equals D. Or I could flip that around, actually, I don't know, I just like it better written the other way. D equals T over m plus 21. Either one is fine. Once I've solved the equation for D, that was the first thing that it asked me to do, then I want to find the total number of days these bees live given this information. So 55 miles per day, that's my m. Total of 500 miles, that's my t. So I'm going to plug that in there. 500 over 55 plus 21. Plug that into my calculator. And that tells me these bees are going to live approximately 30 days. Not a very long lifespan. All right, that's it for this lesson. Write your summary down here. What did you learn? Practice your algebra skills because they will appear on your test, even though they haven't appeared on any of your mastery quizzes. Actually, if you want to pause your video, do that right now, and then I will make the answers appear. I won't talk them through, but I will give you the answers. All right, here are your answers. So go ahead and check. Maybe pause your video if you need a minute, and then I will see you in Zoom.